Hello everyone. Today I will introduce product rule of derivative. The product rule has a wide range of application in many fields such as physics, engineering, and economics. It is useful in calculating power, moment, or forces and other related physical quantities. The product rule allows us to more accurately describe and calculate the rate of change of complex system involving function of multiple variables. Now, I'm going to explain the product rule of derivative. Since f of x is the product of two binomials, we can write f of x equals g of x times h of x. Can we use the product of g prime of x and h prime of x to find f prime of x? Let's try an example. Let g of x equals to x squared minus 3 and h of x equals x to the power of 5 plus 2x. Then g prime of x equals to 2x and h prime of x equals to 5x to the power of 4 plus 2. If we multiply g prime of x and h of x, we get g prime of x times h of x equals 2x times x to the power of 5 plus 2x equals 2x to the power of 6 plus 4x squared. But if we multiply g of x and h prime of x, we get g of x times h prime of x equals x squared minus 3 times 5x to the power of 4 plus 2 equals 5x to the power of 6 plus 2x squared minus 15x to the power of 4 minus 6. Clearly, this is not the same as f prime of x. In order to determine the derivative of a function that is the product of two other functions, we must use the product rule. The product rule states that f prime of x equals g prime of x times h of x plus g of x times h prime of x. So, for our example, f prime of x equals 2x times x to the power of 5 plus 2x plus x squared minus 3 times 5x to the power of 4 then plus 2. So by using the product rule, we can correctly find the derivative of the product of two functions. So now in this slide, the product rule states that the product of two differentiable functions f and g is also differentiable. Additionally, the derivative of the product f and g is given by the first function times the derivative of the second function, plus the second function times the derivative of the first function. So in the mathematically, it is expressed as follows: the derivative of t times g with respect to x is equal to the derivative of f of x times g of x plus the derivative of g of x times f of the x. In symbols, it looks like this: the derivative of f times g of x is equal to the derivative of f of x times g of x plus the derivative of g of x times f of x. Now, let's break it down. First, take the derivative of the first function, f of x, and multiply it by the second function, g of x. Second, take the derivative of the second function, g of x, and multiply it by the first function, f of x. So the formula is the derivative of f of x times g of x plus the derivative of g of x times f of x. So to summarize, the derivative of f of x times g of x is the derivative of the first function times the second function. So in the conclusion, the derivative of g of x times f of x is the derivative of the second function times the first function. By using the product rule, we can find the derivative of the product of two functions efficiently. Now, here is the example 1. The product rule states that the product of two differentiable functions is also differentiable. So, before we start, the derivative of the product of two functions is given by the first function times the derivative of the second function plus the second function times the derivative of the first function. So let's consider the example where we need to find the derivative of h of x, which is equal to the product of x squared and the quantity x cubic plus 8. So the solution we start. The first, we take the derivative of x squared multiplied by the quantity x cubic plus 8 and then add the derivative of the quantity x cubic plus 8 multiplied by x squared. So the derivative of h of x is equal to the derivative of x squared times the quantity x cubic plus 8 plus the derivative of the quantity x cubic plus 8 times x squared. So next, we can simplify the derivative. The derivative of x squared is 2x. Then the derivative of the quantity x cubic plus 8 is 3x squared. Now, we subtitle these values back into the equation. The derivation of h of x is equal to 2x times the quantity x cubic plus 8 plus 3x squared times x squared. Simplifying this, we get the derivative of h of x is equal to 2x to the 4th power plus 16x plus 3x to the 4th power. So finally, combining the like terms, we have the derivative of h of x is equal to 5x to the 4th power plus 16x. So in the summarize, the derivative of h of x, which is the product of x squared and the quantity x cubic plus 8, is equal to 5x to the 4th power plus 16x. Then here is the example 2. Let's look about the example. We have a function, let's call it f of x, which is equal to 3x minus 2 times 4x plus 1 times 6x squared minus x. Then to find the derivative of this function, which we will call f prime of x, we need to use the product rule because one function is made up of 3 parts multiplied together. Let's define each part. Let p of x be 3x minus 2, q of x be 4x plus 1, and r of x be 6x squared minus x. According to the product rule, to find the derivative of f of x, which is p of x times q of x times r of x, we need to take the derivative of each part individually and then use them in our formula. The derivatives are as follows. The derivative of p of x, which we will call p prime of x, is 3. The derivative of q of x is, we call it q prime of x, is 4. The derivative of r of x, which we call r prime of x, is 12x minus 1. So Now we can apply the product rule. F prime of x equals P prime of x times Q of x times R of x plus P of x times Q prime of x times R of x plus P of x times Q of x times R prime of x. So plugging in the value we calculate, we can get the f prime of x equals 3 times 4x plus 1 times 6x squared minus x plus 3x minus 2 times 4 times 6x squared minus x plus 3x minus 2 times 4x plus 1 times 12x minus 1. And we can also simplify this expression to 288x cubic minus 126x squared minus 14x plus 2. So today teach is until here. Then if you can go to our website to do the exercise. Yeah, that's all. Bye bye.